Start the recording. Good. And I'm going to share the screen just to show you what I've got so far. And then my plan was to just go ahead and start working through, well, let me get to the review resources for final is kind of where we're at right now. Let's see. Let's get everybody added in. So we've got the two videos. One is the Zoom recording from Wednesday, and the other one's a video I made after Wednesday afternoon, I think it was. So those have the first section, so that takes care of 13.1, 2, and 14.1. Today I've got it set up where we could go through 13.3, 13.4, and 14.5.
Hey, Professor.
Yes.
Quick question.
Okay.
I know you said the final is on Thursday, but you never mentioned the time.
It is in the syllabus. It's at, I believe, 7 o'clock.
In the evening?
Yes.
Okay.
Yeah, and I know it's. I've had some contact me. They're back East Coast now, so it's going to be late for them. But it's the time we've been assigned, and since we are doing this proctoring, I've got a proctor lined up for that time. I really don't have the option of having multiple proctoring. So.
Right. Okay. Thank you.
Sure. So I'll get another announcement out, but it's in the syllabus. I believe it starts at 7. It might be like 7:10 or something, but 7 sticks in my mind. So if there's no other questions, let me get someone else admitted. This one's, let's see what's this doing. I'm not sure. So. There we go. Get this guy over to this screen. So you can all see the problems. Is that correct?
Yep.
Yep. Okay. So we'll start with the 13.3, which are Riemann sums and evaluating definite integrals. Now the homework problem only had you do left Riemann sums, but so we'll work through these as well. A few of them you can use the calculator. But some of them we're going to we'll do it without the calculator as well. Okay.
For the test, is it only going to be left hand?
Yes, it'll only be left hand.
Okay.
Because that's all we went over. What's that?
What do you mean by left hand?
Left hand Riemann sums. You'll see when we get down to them. Or review that section. So it's just going from the left side of the function.
Oh, so it's easier on the exam?
I don't know if it's easier, but that's all we've done is left-hand Riemann sums. We didn't do right-hand or center Riemann sums.
Okay, so don't do right hand or center, just assume it's left?
Yeah, they'll say, it says left-hand.
Okay.
So do a left Riemann sum.
Yes. Thanks.
Okay. So let's start with this one. And I'll go through and do the actual integration. Okay, we're all good. So each of these will integrate. So again, we're adding 1 to the exponent, so it becomes x to the 6 divided by 6. So this 6 comes down, plus 15, it's going to be x to the 5th. Divided by 5, again, add 1 to the exponent, divide by the exponent. This is going to be, keep admitting folks here, this will be 9x to the 3rd, because 2 plus 1 is 3, again, divided by 3. And the last one just becomes x, because a constant integrator, or 1x if you want. And then what we're going to do is go from 0 to 1. We can see this will simplify down the 6 divided by 6, so we get x to the 6. 15 divided by 5 is 3. 9 divided by 3 is 3. oops, plus x. And again, to evaluate this, you plug in 1 in the front, so we're going to get 1 to the 6th plus 3 times 1 to the 5th minus 3 times 1 to the 3rd plus 1 minus everything to the with a 0 plugged in, but notice as we plug in a 0, everything becomes 0. So I'm just going to do a shorthand minus 0. So this gives us 1 plus 3 minus 3 plus 1. That's 0, so our answer is 2. Is that good? And again, you could do it with a calculator. Just plug this in, the original one here up into y equals, do second calc, and then do the limits from 0 to 1. You should also end up with 2.
So it's just like just like plug in the value for 1 and plug in the value for 0 and then subtract those two answers.
Correct.
Okay, and
Well,
that's the last Riemann sum.
Well, this is evaluating the definite integrals, just like we did here. So we won't be doing left Riemann sums until we get to number 7.
All right.
Okay.
My bad.
No worries. No worries. Here we go. And let's see. There you go. So just as a reminder, let's clear these out. So what that looks like, 6x squared plus 15. Oops. I'm going to do a zoom standard. There's the graph. Second calc, number 7. Lower limit is 0. Upper limit is 1. There's the part that's equal to 3. Where did we?
Professor, I think you put 6x squared instead of 6x to the 5th in the equation.
Oh, thank you. Okay.
No.
So yeah, somebody's watching. That's good. Okay. Yes, this makes a difference. So some of these, I mean, you can put them in, but you have to have the right stuff in there. Good. That's better. I'm glad that that was the error and not that I made an error on the other side. So then we try that again. And again, what it does suggest is when you're doing the test, work it both ways. Even though this, you may have, okay, yeah, 2, I felt fairly confident. It's, if you do it 2 different ways and they don't match up, you make sure you check both what's going on, okay? So, and again, some of these are going to be multiple choice, so all you have to do is choose the right answer. So on this one, let's start, since we've got the calculator here. It's a little easier to put in. We can just put in x plus 5 divided by x. So that's our function. We go to graph it. And we're going to go second calc. Number 7, lower limit is 2 from the integrand. And then we're going to go to the 7. we see we got this part. We got 28.76385, which is telling me if you recognize this 5 over x, that's a natural log. This one may want us to have an exact answer. Now, again, if it is a multiple choice, you could take those multiple choice answers and turn them into decimals, but let's go ahead and work through this, and I'll show you how the answer may appear. So again, we integrate each piece. X, this is x to the first, so we get x squared divided by 2, so added 1 to the exponent, divide by that. This one is 5 over x, or 5 times x to the minus 1. Either way, it's going to integrate as 5 natural log of x. Then we go between 2 and 7. Let's get a little bit more room. So we first plug in the 7.
I have a question.
Okay.
You just showed us how to do it on the calculator, right?
Yes.
Is this like just another way of doing it, or was that just, is that like the first step of the problem?
These are 2 different ways to work the problem. So our answer, numerical answer, is 28.76. However, as you'll see in the web assigned homework, sometimes they won't accept an approximate answer. They want the exact answer. So
right.
now,
So on the exam, though, if I did it like that, like the first way, not this way, would I get full credit? As long as I wrote down like, hey, I used the calculator. This was the steps I used. You know what I mean?
right. On the multiple choice, though, you might not see that answer. So then you'd have to know how to turn it into that. Again, because there's 10 of the questions, you're just going to choose A, B, C, or D.
Right. Okay. So doing it on the calculator, you just go to second calc, right? And then 7. That's
right.
Okay. Thank you.
Sure.
We have to show work for the multiple choice.
You do not. You do not.
Response.
However, if you do, I can review. Since I'm going to be reviewing the other parts. If you choose the wrong one, but you've got some correct work, it'll help me because I want to give you as many points as I can. But it's not required. It's not required.
And then it's 10 multiple choice and 4 free response.
You got it, yeah. And the 10 multiple choice are worth 6 points each. So that's 60% of the test will be multiple choice. The 4 open-ended essay type questions are 10 points each. So that's 40% of the score.
All right, thank you.
Good questions. Thank you, guys. Okay, so what we're going to get here is 49 over 2 plus 5 natural log of 7. And this negative is going to distribute. So this is 4 divided by 2, which is 2 minus 5 natural log of 2. 49 divided by 2 is going to be 24.5. And then we could subtract the 2 from that. So that's going to give us 22.5 plus 5 natural log of 7 minus 5 natural log of 2. So this may be the multiple choice answer you see. If you plug this in your calculator, you should also get 28.76. So that's another way. When you go through the test, you may not, again, if you use the calculator, you might not see the answer 28.76. So then you've got to figure out which one of the values that they're giving you is actually 21 or 28.76. Does that make sense? Hopefully. So be able to realize that they may be giving you the exact answer. So this is our exact answer. Again, assuming I didn't make any errors, so I need you guys keeping on top of me. I've been up since 4 a.m., but I still feel pretty fresh. I've had 3 cups of coffee so far. So it's busy times for us all, right? We're just good to keep moving forward. Okay, so this one, we're going to rewrite this one as x to the minus 2. And again, this one you could probably put in, but again, you're probably going to get decimals. So we'll do it kind of both ways just so you can match it. You can plug it in your calculator, go from 1 to 10. But let's integrate this, add 1 to the exponent. So that gives us x to the minus 1, and then divide by that new exponent. So our answer is going to be negative x to the negative 1. And it's going to go from 1 to 10. So we plug in 10, so we get negative 10 to the minus 1 minus negative 1 to the minus 1. 10 to the minus 1. So this becomes a fraction, so they might leave it as a fraction as minus 1/10. 1 to the negative 1 is still 1. You get minus minus, you get a plus. So you get a positive 1 minus 1/10. So your answer might just simply be 9/10, which tells me if you plug it in the calculator would have given us the answer 0.9. And hopefully you can realize that that's 9/10. So again, if it was multiple choice, you'd be able to do that. Okay. Keep going. And again, we'll get as many of these as we can. I'd like to get them all done if we can, but we'll at least get through maybe these first 2 sections, and then I'll make another video on the rest. Okay. So this one, when we integrate, it's just going to be e to the minus x plus 6, because when we integrate e, we just get it back. And then we've got a constant multiplier here of negative 1, so we have to multiply by the number in front, or sorry, divide by that negative 1. So that is one of those shortcut rules. So this is the integral, so we get minus e to the minus x plus 6 as our integration. We go from 0 to 6. So we plug in.
Once we have that, can we just put that in our calculator?
Possibly. I mean, you'll still get a decimal answer, but what you've got to do with this is you've got to plug the 6 in up here and then the 0 over here.
Okay.
Yeah, so if you're going to use a calculator, I would just at the start, you just put this in and do that second calc option number 7 with the boundaries. We'll take a look at that, but let's put this one in to get the exact answer. So you put in the 6. Then we subtract. We put in 0 for x. Oops. So negative 6 plus 6 is 0. Negative e to the 0 is 1. So this part just becomes negative 1. This one, we're going to get a negative and negative, so that's plus. Negative 0 plus 6 is e to the 6th. Okay. Now, if you put e to the 6 in your calculator, you'll get an approximate answer. So again, this is one, if they have an exact answer, it's going to look like this or this. They could have either one, they're both the same. Okay. So this is one that if you put it in, you'll get the decimal approximation. Okay, so help me out on this one. This integrates into what? I'll give this started. E to the 3x. So we just kind of rewrite it. And then what else do I need to do to integrate this? Anyone help me with that? I need to divide by something. No help? 3, you got it. Good. I just want you to think, so we divide by the exponent. Okay, that's the integration. Going from -1 to 1. Again, we plug in the 1 first. So this is going to be 5/3 e to the 3 times 1 minus 5/3 e to the 3 times -1. Okay. So in the front, 5/3 e to the 3rd, and we're going to leave that because that's an exact answer. Here, this becomes negative e to the -3. We could just leave it that way. And that would be our answer. Again, an exact answer. Yeah. And you'll see with these, the same similar thing's going to happen. It looks really messy, but it's actually going to end up very clean because 2/x integrates into 2 natural log of x. So just remember that when the 1/x integrates into natural log of x. And again, we go from e to the 3rd until e to the 5th. So we plug in the top first and the bottom part second. And remember, when you take the natural log of e, that since they're inverses, they cancel out. So this natural log of e to the 5th just becomes 5. So we get 2 times 5. Over here, we get 2 times 3. So that gives us 10 minus 6, which is just 4. Okay, almost through these. And we're going to see similar things when we have natural logs and e's, those things cancel out. So it's going to look similar, but this part integrates into e over to the 2x divided by, think about it, you're right, 2. I knew you were thinking about it, right? Because that's that exponent. And then again, we're going to go from natural log of 3 to natural log of 5. So we plug in the top boundary first. So e to the 2 times natural log of 5 over 2 minus e to the 2 times natural log of 3 over 2. Now you still probably won't see this. What you have to remember a little bit from your algebra, when you're multiplying natural log, that this 2 actually becomes an exponent. So this becomes e to the natural log of 5 squared over 2 minus e to the natural log of 3 squared. So that, because we're multiplying, it becomes on top. What's e to the natural log of 5 squared? 5 squared is 25. So this first part just becomes 25 over 2. The second part becomes 9 over 2. 25 minus 9 is 16 over 2. So 8 is our final answer. Okay. Again, you could have done this one with the graphing calculator. I'm not sure if you would have gotten exactly 8 or not, but you would have got close. We okay with those so far? Any questions? Okay. Give myself some room here. There we go. This one's a little bit different, but it's using sort of some problem solving. And then as you can see down here, we're going to get into the left Riemann sums. Okay, so this is solve the following equation for B. So what we're going to do is we're going to integrate it, plug these things in, and then since we know the answer is 9, we'll be able to solve for B. So 2x.
Will there be a question like this on the exam?
It's on the review, so I would be willing to know it. I
For the
can't tell
exam,
you. What's that?
For the exam, are you creating the questions or are you pulling like ones off WebAssign?
They have been created by the coordinator. So the coordinator, so everybody in 210 is taking the same exams. They've actually made 2 different ones, but so we are taking one that the coordinator has created. The coordinator is also the one who created this review. So and I've looked at it, it's more like this review. So the questions are very similar to the review questions here. And they're not like the WebAssign homework questions.
Okay, thank you.
Sure. Okay, so when we integrate, this one's going to become 2x squared divided by 2, right? Add 1 to the exponent, minus 4x. And then we take it from 2 to b. So the 2's are going to cancel. So this is just x squared. So we're going to get, we plug in the b, we get b squared minus 4 times b minus, plug in the 2, minus 4 times 2. And what we know is that all of this is equal to 9. So that's where the 9 comes from. So in the end, we get b squared minus 4b. 2 squared is 4, so we get minus 4 there. And then this has to distribute, so this minus and minus become a plus. 4 times 2 is 8. So we get b squared minus 4b. This becomes plus 4 equals 9. The best way to solve a quadratic is actually get it equal to 0. So we'll go b squared minus 4b. Subtract 9 from both sides, we get minus 5. And so this one, you could solve it by equals 0, you could solve it by graphing, or you could solve it by factoring it. But it might be a year or 2 since you've done that. So actually this one though ends up with 2 answers. This one we add 5 to both sides. B equals 5. This one we subtract 1 from both sides. B equals -1. Could it be both of these? Well, since B is an upper limit, it has to be greater than 2. That's when we put these limits, the upper limit has to be beyond the lower limit. So that tells us B has to be 5.
Professor,
Yes.
it says in the questions, assume that B is a positive number.
Okay, oh, yeah, read the question. So that also helps, but if you miss that part like I did, you know that the upper limit has to be larger than the lower limit. But thank you. So it does, either way, it allows us to not have to worry about this one. Good, thank you. Okay. Riemann sums. And Again, there is a question out of each of the sections, so there, I would assume there is going to be one on left Riemann sums. So what we do for the left Riemann sum is we are going to, this is getting towards the integration. We're going to use, what we did is we graph the function and we take from the intervals from 1 to 3 and divide the x-axis into 5 units. Okay, so we're going to go from 1 to 3. So the way we decided how many Riemann boxes we're going to get is we would take 3 minus 1, the limits, divided by however many we're going to make. Okay, so you take your limits, subtract them, divided by the number n. So we get 2/5. 2/5 is 0.4. So what that means is when we go, we're starting here at the left. So whatever that function looks like, we're going to go make a Riemann box going from 1 until 1.4. At 1.4, we're going to get another Riemann square. So I'll do the graph later, but let's go ahead and do it. So we're going to go from f of 1, f of 1.4, and notice how I'm just going to keep adding 0.4 to these, f of 1.8, 1.8 plus 4 is going to get me to 2.2. And notice I've got 1, 2, 3, 4 so far. So the last one, add 0.4 to this, that's going to be 2.6. And notice if you added one more, 2.6 plus 0.4 gets us to 3, which is the end. But this is a left sum because these are the left sides of the box. So there is a box right here at 2.6. And again, the function comes down like this somehow. Okay. So what we need is we need these function values. And the way we're going to do that is we're going to use our graphing calculator. We don't actually integrate. We're just putting this function in there. (3x squared plus 2x minus 3). And then since this is the intervals I need, what I'm going to do is if you go to your table set, so second table set, I'm going to start my table at 1, and I'm going to have the table change by 0.4. This maybe would have been a smarter thing to do first. Then you'll see these will be right in the table. I want to make sure my independent and dependent are both on auto. And then I'm going to go to table this time, second table. Notice I've got 1, 1.4, 1.8, 2.2, and 2.6. The y values is what I'm going to write down. I forgot how to, let's see. Do a little trick over here.
Excuse me, Professor.
Yes.
So we never include the last value, right? In this case, 3.
Correct, because we're doing the left-hand side, so that last value is always incorporated in sort of is, yeah, we're doing the left-hand side of that box.
Got it, thank
you.
Good
Thing to know. So this is 2, this is 5.68, and actually if you come over here, you can see if they've been rounded any, but yeah, to 2 decimal places. This is 10.32. This is 15.92, and this is 22 0.48. So those are the heights of the boxes. What we need to do to get area is its base times height. So what is our base? Our base is this 0.4. So then now it's just a tedious calculations. We need to multiply each of these by 0.4. That will give us our areas for each of these. And then we have to add it all together.
Would you just add them all together and then multiply by 4?
Yeah, that's another way. Right. In fact, that's the way the text does it. I like doing, conceptually, this is we're getting the areas of each box, so you do it this way. But mathematically, yes, you can just add them together and then multiply by 4. Why don't we do that? I think that'll save us, right? That saves 5 calculations. So smart suggestion. So we'll add them. 2 plus 5.68. Oops. Let's start again. 2 plus 5.68 plus 10.32 plus 15.92 plus 22.48. And hopefully you were watching, looks like we got it all correctly. So that's 56.4, and then we multiply that by 0.4. Which is 22.56. Okay, so we added these. Oops. This gave us 56, let me go, 56.4. Let's back up. I'm not sure. Well, anyway, we'll see if I can get to the next one. Our final answer would be 22.56. And it looks like the answer will stay in place. I'm not sure what happened here. Okay. So that's a left Riemann sum. This one's going to, what I'm going to do with this one, I'll get it set up for you. And then we'll, okay. So for this one, our limits are 2 to 3. So we do 3 minus 2. And we're going to do it in 4 subintervals. So divide by 4. 3 minus 2 is 1. So that's 1/4 or 0.25. What we put in the calculator, we don't integrate this actually, which might be messy to do anyway. We put this as our y equals. And just a reminder, if you have the right software, if you go to F1, so alpha y equals, it'll actually allow you to put in a fraction in over D. So I like to do that just to make sure, because this is one where if you don't use your parentheses correctly, you won't get it entered correctly, and so your answers won't be correct either. Okay, so make sure it either looks like this or you have a parentheses around the bottom. We're going to go to table set, second table set. We're going to start at 2 this time. And this time the table change is going to be 0.25 because of our subintervals are 0.25 wide. And then we go to second table. We take the first 4, so we're going to go 2, 2.5. or sorry, 2, 2.25, 2.5, and 2.75. Notice we do not take the last one. We would add these numbers together, and then once you've got that, you multiply by 0.25. Okay, so we sum those together, multiply by 0.25. And the answers are in the review PDF. So I'll rather than going through the TV side of doing it all, we'll let you check your answer on that. Okay, what time is it? 11:20. Okay. So let's do a few of these, at least get them set up. And let's see, how many do we have? We've got 4 of them. With these ones, yeah, and these are similar to ones I think we've done before anyway. But these ones we can do with the calculator. Okay, so this one we're going to do particle moves in a straight line with velocity meters per second, where t is time in seconds. Find the displacement of the particles. That's the location, and the displacement of the particle between this. It's an accumulation. It's the integral. So we're just finding the integral from 2 to 6 of minus t squared plus 8 dt. Okay, since we don't have any funky natural log or e's, we can just go ahead. This one we can find by, there we go. We're going to graph the function. So we get minus x squared plus 8. We're going to go from 2 to 6, so we just go to the graph. Two to 6 minus, okay. Number 7. Lower limit is 2. Upper limit is 6. And because velocity has direction, it evidently changed direction. We get negative 37.333. If you wanted an exact answer, what you have to recognize is 0.333 is 1/3. So you could turn it into a fraction if need be, but negative 33.333. Okay. Marginal revenue, X box of flashcards sold is this. So that's a marginal. The revenue generated from selling 101 to 5,000. So what we get is we get the integral 101 to 5,000. So that's what we're looking for. Let's go ahead and do it graphically first. Okay. And again, if you need to leave, we're getting close to the end. You're welcome to, but if you want to stay, I'm going to keep recording and I'll post this. Now our limits go from 101 to 5,000. So what we need to do is have our X values go out far enough. We could leave it at -10, but we need to go at least to 5,000. So I'm going to go to 6,000 just to be on the safe side. Our Y values, this is a negative exponent 500. I'm just maybe Y max at 500. And let's see if that gives us a good, yeah, that was a good call. So we've got this sort of thing going on and it's getting smaller and smaller. Again, we go second calc, number 7. The lower limit's 101 and the upper limit is 5,000. Fills it in. And we get 4,000, let's see, what is that? 448,597. 448,000. Yes.
Is there any I keep getting like an error on my calculator every time I try and use the calc function. I'm not entirely sure why.
When do you get it? Does it graph it? Do you go to graph first?
Yeah, I graph it and then I do 7 the f of x dx and then I put in the minimum and it'll just say error. So it doesn't happen every time. It only happens like on certain problems. This is like one of them.
When it says error, what does the error message say? Does it anything more? Does it say like domain error?
Just says error invalid, attempted to use a variable or function where it is not valid.
It could be your window was not large enough or didn't include the value.
Okay.
That's a possibility because, yeah, watch if the reason I changed my window, watch, I'll do 4,000. And maybe I'll go to 200. Maybe you've already done this, but if you go to this graph, let's see if I get that same error. Go second calc 7, and I tried to put in 101. Okay. Yeah, I get it invalid. So your window size has to include the values that the boundaries.
Okay. All right. Thank you.
You're welcome. Good. It's good. You got to find those errors. And that's, yeah. Okay. And the reason we could do it this way is because it was asking for revenue, and the answer gives it rounded to the nearest dollar anyway. So we didn't have to worry about trying to make it exact. Okay. So that's a nice little revenue for selling some flashcards. Okay. Hopefully you remember this one was very similar to one that we did in Alex, and I've got a recording of it. We're going to integrate this function. And the thing is though some people were going from 0 to 9, that's just saying the function's good from 0 to 9. 0 is year 2005, so what we have to do is we have to go for these years. So 2007 is 2 years, and 2010 would be 5. So our boundaries are going from 2 to 5. Okay, and so estimate the total number of hours of video upload, and since it's an estimate, we will graph this as our Y1. Graph it, do 7 calc, and then do our boundaries 2 to 5. So let's see if that works. Oops, I have to hit enter. So again, 1.1 x squared minus 2.6 x plus 2.3. And for our graphing window, we're going from, this is only going from 0 to 9 anyway. So again, we'll go to our window. Let's go from 0 to 9. The Y values, I don't know. Let's go to 50. Just so we can see. Yeah, actually, I could probably come down. 50 was a good shot. And then again, we're going to go second calc, number 7. And we're going to go from from t value equal to 2 to 5. And that's what we've got there. So it's 22.5 would be our answer here. So calculate the area region bounded by y equals square root of x and the x-axis. And the lines x equals 0 and x equals 16. So what does this all mean? Well, the area, what we're getting is area under the curve. So it is, yeah, between the curve and the x-axis, x equals 0 to 16. These are our limits of integration. Okay, just phrasing it differently. So we're going to go from 0 to 16, square root of x dx. Again, you could write this as x to the 1/2 power. But again, we will also be able to do it with the graphing calculator. So we just graph square root of x. And we're going to go from 0 to 16, so I want to make sure my window includes all of that. So 0 to at least 16, you might go more if you want, but you got to at least have that boundary. 50 is probably more than we need. Let's go to 20. Yeah, probably could have done less, but second calc, number 7, I hit the 7 key, and the lower limit is 0. The upper limit is 16. Fills in, we've got an area of 42.6667, and hopefully you can recognize that looks like 666705. That's close at least to 2/3. It's not exactly 2/3, but it'd be close to 2/3. We could round it to 42.67. Okay. Yeah, and when you go to show work, you can, on something like this, I would suggest sketching the graph. You know, if this was an essay question, I would take a quick sketch and say, you know, this is my graph, like this. I got this. It helps out, you know, set it up like this. But then, yeah, in the end, if you've used your calculator, this is a, you know, this is a perfectly good work. And I think that they're, you know, but again, those will probably be for the multiple choice ones. So we're a little bit over. I can hang around if there are some more questions, but how about if I do the improper integral, which is kind of going to be the same thing with limits. We've got about 5 of them. Let me take a little break and I'll make a video and post that if that's okay with you, unless someone wanted to see a particular one or any other questions. So I'll send it back to you guys.
Professor?
Yes.
Are there going to be any more of the quizzes things?
My question to you is, would you like some more?
I would. It did help.
You would. Okay. And you know, they're not there really to hurt your grade. They're there to help your grade. They do take me, because to make them good, I've got to get some good wrong answers there to. But yeah, I think they would. I would like to have them if I were a student because they'll practice with the multiple choice. So yes, I will make some over the weekend. I have no problem. And so at least attempt them. What I'm going to do, I'm not going to score them, but if you'll at least attempt them, that's going to help you with the grade, with the test. So I will put them out there for those who want to. And I did take a look. Most of the majority of you have been working through them. So I will make this weekend, kind of today was my deadline for a lot of other things too. So a lot of burden comes off of my personal plate after this. So this weekend I will put them together so that we have them. A question I have for you as well is, how about, do you foresee any need to meet next week? We don't have regular office hours. We don't have regular.
I think like a review sessions Monday, Tuesday, Wednesday, like this, like we're doing right now, just like free form or go through it like from the beginning to the end. Like this would be super helpful, and you should make an announcement to like all 90 or 100 students or whatever, because you the man, little crow.
Thank you.
Everybody clap.
Well, I'll tell you what, I could do it either Tuesday or Wednesday. I'm proctoring exams on Monday.
We should take both. We'll do Tuesday and Wednesdays.
There was a Tuesday or Wednesday.
Oh, I'm sorry. My humble apologies.
There is also, in the make you aware of, there are also these review sessions. There's one on Thursday. Well, that's already passed. That was yesterday. There's one on Sunday, 7 to 8:30. Those are being put on by the Tutor Center. I recommend them just to get a new perspective on things. I think they'll be posting the review, the recordings, but if you can make them on Sunday, I would recommend that. So who's got a choice? Is it Tuesday or Wednesday?
I think Tuesday's a good day.
Okay.
But I also think Wednesday's a good day too.
Well, let's do Tuesday. And
But Connor wants to do Wednesday. Connor, pipe up. Tell Mr. Lillicrow what you think. He said something in the group chat. Yeah, there you go.
I think it would be more fresh in the mind on Wednesday. That's my only thought.
Okay, that's good. Yeah, and you'll have more time to review, because that's what I really want you to do. Is I'd like it to be a session where you've had enough time to really work through everything. So we're working through the questions that still were not there, and I'll agree with you. It would be fresher.
Okay, we'll do Wednesday. I'm
We'll
glad
do
we all
Wednesday.
agreed on it.
Thank you all. So I'll announce that. We'll do it about class time, as just because that's what we're creatures of habit. And it'll be a reminder. So I'll post it as an announcement. We'll have another review session Wednesday, sort of open-ended. But again, if you could work through as many of these questions as you can, come with ones that didn't seem to work for you, or ones you want more discussion on. Okay? But we'll call this meeting over for now.
Thank you, Mr. Little.
Thank you. Have a good day, Mr. Professor.
Yeah, you have a good one, sir.
You too. Take care. Be safe.